Okay, now we're going to continue with section 9.2. We're still doing hypothesis testing of the mean, except now we're going to be looking at the case where we need to use the student's t-distribution. That is going to be whenever we do not have the population standard deviation. If we do not know sigma, we will use the student's t-distribution. The requirements and the procedures are very, very similar. So let's look at the requirements. We still have x as a random variable. We have a sample size n. We take the sample mean. Now we are going to take the sample standard deviation s, the sample standard deviation, because we don't know sigma, the population standard deviation. If you can assume that x has a mound shaped and symmetric distribution, or that's fine. If it's normal, great. If we don't know it's symmetric and mound shaped, then let's have a large sample size, or at least 30. So let's see. Look at our procedures now. Our first step is still to find our null and alternate hypotheses and notice our level of significance. The second step is still to find our test statistic, except now we're looking at our t as our variable. So notice the formula is almost exactly the same, except you use s in place of sigma. So between finding z and t, the distinction is you're going to be using s. So you had z was x bar minus mu over sigma divided by the square root of n. You replace that sigma with an s, and then you have your t distribution. Okay, so that's your test statistic. The mu you are using is from your null hypothesis. Third step, finding the p-value. So we're going to have to learn how to use our t-table for this. It's going to be slightly different than how we use the t-table in section 8.2. So that will be something new. But the idea is that we're going to be getting a p-value and comparing in the fourth step the p-value with our level of significance. And the same step 5. Now let's look at a particular example. Okay, so this example, we have a drug 6-MP is used to treat leukemia. The following data represent the remission time in weeks for a random sample of 21 patients using this drug. So, for example, this patient had remission time of 23 weeks, whereas this patient had a remission time of only 6 weeks. Of this sample of 21, the sample mean is 17.1. If they're giving you all the data like this, they don't have to give you the sample mean or the sample standard deviation. You now know how to calculate the standard deviation on your calculator, so it's very quick. If you want to practice that, now would be an admirable opportunity to put these 21 data in your list 1 in your calculator, see if you can calculate the standard deviation. Just check yourself on these two measurements with these 21 data values. Okay, so let's say that you verify that x bar is 17.1 and you verify that the standard deviation is 10, which you could do because you actually have the data right in front of you here. What are we going to do? Let's continue. So x is our random variable representing the remission time for all patients using 6-MP. Assume that the x distribution is mound-shaped and symmetric. Okay. A previously used drug had a mean remission time of 12.5 weeks. So here comes our question. Do the data, this 21 value set, indicate that the mean remission time using the drug 6-MP is different, either way, from 12.5 weeks? We're going to use a level of significance of 0.01. So we're asking, do these data indicate that it's any different than the old drug. The old drug had a mean remission time of 12.5 weeks. Our particular sample certainly has a higher remission time, 17.1 weeks. But is it significant? So let's go through the same procedures and see how it goes. So the same procedures A through E. Our first step is to establish the null and alternate hypotheses. For that, it's very useful to look at the last sentence or two. Usually the question is embedded there. So what would our null hypothesis be? Our null hypothesis is a statement about the mean. Our null hypothesis is going to be a statement that the mean equals something. In this case, we're comparing it to our other drug, the mean remission time of 12.5 weeks. What is our alternate hypothesis going to be? It'll be a claim still about the mean, still about 12.5. The distinction now is that we want to look, do the data indicate that the mean remission time is different? Just different. So I'm just going to say not equal. It doesn't say bigger, smaller, just not equal. Okay. Okay, so we have our null and alternate hypotheses. Let's check the requirements. Are we going to be using the student's t-distribution? Are we going to be using a normal distribution? Which is it? Okay, so in this case, what do we know about our x distribution? X is assumed to be mound-shaped and symmetric. That's enough for us. Is it normal? I don't know. What about our sample size? Our sample size is only 21. Fine. So we don't know that x is normal. Our sample size is relatively small. It's only 21. So we don't know that x bar is normal. That's fine. We're not going to be using a normal distribution then. And we don't have sigma either. We only have the standard deviation of the particular sample. So we'll be using t for our test statistic. So t is x bar minus mu divided by s over the square root of n. So what would that be in this case? What is our x bar? Our particular measurement was 17.1. The historic average for the other drug was 12.5 weeks. And s is 10, and the square root of 21. Our sample size is 21. So before we go ahead, this would be a good opportunity to get some calculator practice in. Pause the video, see what you get. You might want to put parentheses around your denominator when you use your calculator. Okay, so because we don't know sigma, we'll be using the student's t-distribution. We're keeping in mind that our degree of freedom is n minus 1. When we do get to use our actual t-table, that'll be relevant. And we have the following information. So the test statistic is going to be 2.108. Okay, find the p-value of the test statistic. So this is where we're going to be looking at our t-table in a different way than we did for the confidence intervals. The same table, we're going to be using slightly different parts of it. Okay, so here we have our null hypothesis says that mu is not equal to 12.5, so we're going to be using a two-tailed test. And so we're going to be using a two-tailed test. We're going to use table 4 to find the interval containing the p-value. That's different. Look up the t-value in that row, headed by df is 20. Okay, so something different here. than when we had our z. Our z table, we look up a z value, we get out a number that represents the area to the left. When we look up our t table, we have so many fewer values, we can't say very precisely what the answer is. Instead of giving one value, we're going to be giving a range. So let's look at this example at the bottom here. So this is a little piece of the t-table here. There's going to be a separate video on how to use the t-table in this context. So that's the third video. Let's look right here. We had t is 2.108. We had that it was a two-tailed test. So we're going to look at the green row. There are 3 green rows at the top of your table. We're looking at the two-tail test area. We're looking at the row df equals 20. And we look to the left, we look to the right, and we see that our t value, 2.108, is between these two numbers, 2.086, 2.528. That is our probability. Okay, our probability, we would have to look up and see what it is. So here are t values in the white. We look up to the two-tail area, and I see these two values. So my probability is between those two values, right here, this inequality. So find the p-value of the test statistic is this step. Our test statistic is our t. How do we look up this t? We look up the row df is 20 and minus 1, 21 minus 1. And then we look for the t values that ours is in between. So our t value is in between 2.086 and 2.528. So we know we're going to be between those two columns. We look up to the two-tail area row, and we see that we're between 0.05 and 0.02. So that's our conclusion right there. We don't have a particular number for the p-value, we have a range of values. Okay, so our p-value is between these two. We still need to compare its alpha. So what we are interested in is comparing alpha and our p-value. So here is our alpha. Our p-value could be anywhere between 0.02 and 0.05. So we have a little number line here. Our pink area, that's our p-value. It's between 0.02 and 0.05. 0.01 is to the left. It's smaller. Because the p-value is bigger, we're going to fail to reject. So we need the whole interval to be greater than a to fail to reject. Otherwise, we'll accept. We will reject. So let's look at the results in the context of this problem. So the data, what is the generic answer would be, at the 1% level of significance, the evidence is not sufficient to reject H0. Let's look why. Because our p-value was between 0.02 and 0.05, but our alpha, our threshold, is 0.01. Okay, so at the 1% level of significance, the evidence is not sufficient to reject H0. So let's make that a little bit more personal or particular to this problem. Based on the sample data, we cannot say that the new drug provides a different average remission time than the previous drug. Okay. So now look at the little video that talks about how to use the t-table. We'll look at a few examples for that.